Okay, so in this lecture, we talk about determine whether a relation is a function or not, and then evaluate the value of the functions, or we call that the output given some inputs. Okay. So functions, I'm gonna cover some definition first, and then we're gonna jump into example later. So function. So a function is a relation. Between two values we usually call x and y. With some special property. All right. So there is the relationship between two values, x and y. Okay. And usually this particular statement is represented as follow. You have y equal to f of x. For y in this case is called the output. X is called the input. And f in this case represents function or the special property that we mentioned in the statement. And usually in mathematics or physics or any sciences, when you use letter F, means function most of the time. Are the letters that get used to represent function, including G, H, things like that. Depends on the situation, but most of the time we use F, G, and H for functions. G and H for function as well. So f, the function or the special property, can imagine this particular statement right here as a coffee machine. Okay, so for x is the input, which is the coffee beans. Okay, and y is the output. In this case, the cup of coffee that you're going to get when you put the coffee bean into the coffee machine F. Hopefully that you understand. Okay. So that's you have x is the input, y is the output, and f is the special property or the function in this case that you're going to deal with. All right. In order to process with this information, you need to know more specific information about the x value and the y value. Okay. Because sometimes you need to include the input that is very particular to certain situations. Right. Let's go back to the coffee machine example. You cannot put the carrot into the coffee machine and expect the coffee cup at the end, right? So to make sure that you have the correct input, you need to find something called the domain of the function or the domain of the special property. Okay. So domain is the set of all possible inputs or the set of all possible x values. Right. And another name for the inputs or x value is called the independent variables. And the definitions for, so that is for the x value for independent variable for the input. Now the input, there's a particular name for the set of all possible outputs called the range. is the set of all possible outputs. Right. So for the y values, or the y values has another name, or the output has another name on the dependent variables. Right. So basically, this is kind of like the introductions to functions. We're going to have a more specific definitions or properties of functions later on in this lecture, but this is the definition that I want you to see, that the function is the relation between two values x and y, okay, through a special property. It's called f, it's function. So y is equal to f of x is the input, y is the output, f is the functions. All right. There are four different ways to represent a functions. Right? The first one is is verbally. Using sentences. Right, so the example here is that the circumference of a square is 4 times one of its sides. So that sentence right there represents a function. And remember this, right? Hundreds of years ago, we don't have this symbol to indicate mathematics at all. You don't have x, you don't have y, you don't have pi or something like that. People, when they write mathematics, they write down sentences like this. So a math paper is really long in general because of all the words that represent a certain mathematical formula. Okay, not until like 300 years ago, they developed some symbols so that we can use in algebra to dedicate to mathematical formula. A second way to represent a function is through tables of values. It's called numerically. Tables of values. All right. So in this table of values, you can see, for example, months in 2022 or 2024 for that matter, if you want. You have January, February, so on and so forth until December. And you want to count how many days you have in each month, right? In January, you have 31 days. February, you have 28 or 29, depends on the year. So that's the second way to represent a function. The third way is visually, using graphs. Okay, so you have seen graphs a lot so far in your math career, and eventually if you continue with mathematics, physics, or any of the STEM majors, you're going to see a lot of graphs as well. And the last way is algebraically. That is, you have formula. So for example, you have y equal to x squared plus x minus 2. Eventually, you're going to learn this particular formula is a quadratic function. All right, so there are four ways to represent functions. Now, how could you identify a functions? Right. Given some information about graphs, about sentences, about table of values, about the formula, how would you identify each relation as a function? So to identify a function, right, one input, you need that one input corresponds to exactly one output. Let's write down the definition first, and then I will give you an example to classify this condition or to clarify these conditions. So 2 or more inputs can be sent to one output. The third property is no input can be sent to 2 or more outputs. Okay, so in the fourth point is some outputs may not be matched with any inputs. So some outputs may not be matched with any inputs. Okay, so there are four different properties that allow you to identify if a relation is a function or not. All right, so I'm gonna give you an example, and hopefully this example will help illustrate or demonstrate the idea of these four properties. All right, so in this case, I have two different sets. On the left-hand side is the set of all the names, and on the right-hand side is the set of all the months. Okay, so my name is Winho, and I was born in January, right? So let's say somebody else named John, okay, and he was born in February. Okay, so I was born in January, so one input corresponding to one output. And John was born in February, so that again, one input corresponding to exactly one output. Now, there probably another name, so I can call it Jane. Jane can be born in February as well. So two or more inputs can be sent directly to one output, right? However, no input can be sent to two or more outputs, right? So it does not make sense for me to be born in January and in February. So it does not make sense, right? So that's example right there, illustrate the third statement. And the last statement is that, for example, we just have a list of 3 names, but you know that there are 12 months in a year. So all the months from March, April, May, June, July may not match with any inputs at all, right? So hopefully this example help you understand the properties that we just wrote down earlier. Okay, so now in example 1, you are given some relations, and you want to identify if the domain in the range of this relation, and make sure that determine if the relation represents a function or not. Okay, so in the first example, in part A, or in problem A, you have a set of 4 points: 1, 4, 2, 5, 3, 6, and 4, 7, right? And the point consists of 2 components. The first component is for x, right? So, and the second component is for y. So the domain is the set of all possible x value, and the set is written as the curly bracket or curly braces. Okay, so the domain is the set of all possible x values. So 1, 2, 3, 4. And the range is the set of all possible y value. So 4, 5, 6, and 7. And this relation is a functions, right? Because 1 corresponding to 4, 2 corresponding to 5, 3 corresponding to 6, and 4 is corresponding to 7. So this relation is a function. Now for B, the domain in this case going to be -3, -2, 0, 1. As you can see here, you have a -3, but you already include the -3 in the domain in the set, so you don't have to repeat that again. And for the range, you have 0, 1, 4, 8, 9. So in writing a set, especially for this type of numbers, you want to make sure, especially for the domain and range, you want to make sure that the number is starting from the lower number to the higher number, right? You cannot just arrange the number in random order. So it has to be from smaller number to the higher number. Okay. And this particular example, this relation is not a function because of these 2 points, right? So -3 corresponding to 9 and 8. So you cannot do that. So this is not a function. So next, the domain is -2, 1, 4. Again, the domain is the including all possible x value, and you write the number from the smaller number to the higher number. And the range is -3, 1, 2, and 3. And in this case, again, this is not a function because 1 is going to -3 and 1. So it cannot happen like that. So it's not a function. Now in D, the domain is -3, -2, 1, 4. And the range is -3, -1, and 1. And this one is a function, right? Now you have -2 and 1 going to 1. That is fine, right? So 2 or more inputs can go to 1 output. In E and F, you are given table of values. So the domain here is the set of all possible x value. So you have 16, 64, 81, and 100. Again, even though you have 2 different 81 here, but you just need to write 181. Okay. You don't have to repeat the number again. And the range in this case going to be -9, -8, and -4, 9, and 10. Again, I know given in the table, the y value given in the table is -4, -8, -9, 9, and 10. But when you write your range or domain, right, make sure that you start with the lower number or smaller number and go up to the higher number. Okay. Now, in this case, this is not a function because you have 81 go to -9 and 81 go to +9. So no, this is not a function. And in the last example, the domain is -112, -60, -18, 30, and 54. And the range is -10, -3, -2, 5, and 9. Okay. And this is in fact a functions. So hopefully this example 1, give you an idea how to identify a function from a relations, right? So given a function, given a relation, given a table of value, can you identify it to be a function? Okay. Now, the next concept is quite important in algebra and pre-calculus or any branch of mathematics, that sometimes you want to find the output value of the functions, right? Given an input, right? So given an input, can you substitute into the function and find the y value? Given x, can you find y? Given x, can you find f of x? Okay. So in this case, you have a function of the form f of x equal to 1 minus x squared. And they ask you to evaluate the function when x is equal to 0. So this means that anytime in the function, anytime you see x, you replace x by 0. That's what that means. So if I evaluate the function, so you have f of x right? So you take out the x and you replace that with 0 in this case, and you have 1 minus x squared. Again, x is removed and replaced by 0. So 1 minus 0 squared, so you have 1 for the answer. Now in part B, x equal to 2, again, you use the same functions, f of x equal to 1 minus x squared. Anywhere you see x, you replace that by 2. So f of x becomes f of 2 equal to 1 minus 2 squared, or 1 minus 4 equal to negative 3. Now for x equal to negative 1, you do the same thing, f of negative 1 equal to 1 minus negative 1 squared, or 1 minus 1 becomes 0. So negative 1 squared is becoming positive 1, so 1 minus 1 is 0. So hopefully this give you an idea how to evaluate the function as a given point. In the next example, example 3 is very similar to example 2, but is get asked a different way, right? So they tell you evaluate g of 2. So that means can you evaluate the function given the input to be x equal to 2? Okay. So in this case, you take out the x and you replace that by positive 2. So you have a negative in front, 2 square plus 4 times 2 plus 1. So you have negative 4 plus 8 plus 1 equal to positive 5. Now, part B, g of t. In this case, you replace a variable x by another letter. So take out the x and replace that by the letter t. So you have negative t squared plus 4t plus 1. For c, you take out the x and you replace that with x plus 2. So you have negative of x plus 2 squared plus 4 times x plus 2 plus 1. Okay. Now in example 4, again, you are given a function f of x equal to 2x squared minus 3x. For this example, you don't need to care about simplifying the functions. I just want you to try to understand how to do substitutions given the value of x. Right, so let's focus on that instead of just simplifying the functions. All right, so given the function 2x squared minus 3x, can you evaluate the following values? So f of 3, that means x is equal to 3. So you do 2 times 3 squared minus 3 times 3. Or this is 2 times 9 minus 9. So 18 minus 9 is equal to 9. Now part B, f of x plus f of 3. So f of x is 2x squared minus 3x plus f of 3. You found it in part A, which is equal to 9. So this is 9. Right? So B is 2x squared minus 3x plus 9. For C, you have 3 times f of x. So 3, and then f of x is 2x squared minus 3x. For D, now you want to evaluate f of negative x. That means you take out the x and you replace by negative x. That is 2 times negative x squared minus 3 times negative x. Or this is 2x squared plus 3x. Right. So negative number here, when you square, it's become positive. Okay. And this two negative combine together and become positive value as well. For E, you have negative f of x, so negative of 2x squared minus 3x. When you distribute negative into the parentheses, you change or you switch the sign of all the value there. So negative 2x squared plus 3x. For F, you have ever 3x. So anytime you see x, you replace by 3x. So you have 2 times 3x squared minus 3 times 3x. So you have 2 times 9x squared minus 9x. And you calculate this, you get 18x squared minus 9x. Again, don't focus too much about simplification at this point. I just want you to understand how to do substitution or evaluate the output of the functions. Now, for the last equation, for the last problem, f of x plus 3. So anytime you see x, you replace by x plus 3. So you do 2 times x plus 3 squared minus 3 times x plus 3. Okay. Now let's do one more example on evaluating the output given some input. So f of x in this case is x squared plus 3x minus 3. And part A, they ask you to do f of x minus 1. Anytime you see x, you replace by x minus 1. So f of x minus 1 is x minus 1 squared plus 3 times x minus 1 minus 3. And for B, when you see x, replace by x squared. So you have x squared altogether square plus 2 times x squared minus 3. Or you have x to the 4th plus 2 times x squared minus 3. And for the last example, f of x plus h, you take out the x and you replace it with x plus h. So you have x plus h squared plus 2 times x plus h minus 3. Okay. So that's it for example 5. Please let me know if you have any questions. Okay. So for example 6, we want to find the difference quotient, right? So you have the difference quotient of the form f of x plus h minus f of x over h. For x, h is different from 0 in this case. Eventually, you're going to see this formula again in calculus 1 at the beginning of calculus 1. So this is the topic that we tried to do last time, that you have the function f of x. Now you want to manipulate the function by substituting a different value of x. Right. So in this case, let's set up the difference quotient for the following functions. So part A, you have f of x equal to x plus 3. So the difference quotient is, so let me write the formula again. That is f of x plus h minus f of x divided by h. So for f of x plus h, you look at the function, you take out the x and you replace that by x plus h. So that is x plus h plus 3. So this, what I just wrote, is for f of x plus h. And now minus x plus 3. All together divided by h. Now let's simplify the numerator as much as you can. Right, so you distribute the negative into the parentheses. You got x plus h plus 3 minus x minus 3 divided by h. Then on the numerator, you can see that positive x and negative x cancel out. Positive 3 and negative 3 cancel out. And you're left with just h over h. And this is equal to 1. Right, so given a function, in this case, f of x is equal to x plus 3, and you want to find the different quotients, you apply the formula and you speak into the results. Any questions? All right. So now I'm going to do a similar problem. F of x equal to 4x plus 3. Okay. So I'm going to write down the formula again, f of x plus h minus f of x all together divided by h. So this is the difference quotient. So f of x plus h is 4 times x plus h plus 3 minus 4x plus 3 all together divided by h. Any questions? All right, simplify the numerator as much as you can. So first, I'm going to distribute 4 into the parentheses, and then the negative into the parentheses. So on numerator, I got 4x plus 4h plus 3 minus 4x minus 3 all together divided by h. Just simplify, you have 4, positive 4x, negative 4x cancel out, positive 3, negative 3 cancel out, and you're left with 4h divided by h, or just 4 for the answer. Right, any questions? So the big part of this calculation is, do you know how to do substitutions, right? You have the function, you are given a function, can you take out the x and replace with something else? That's the big question, right? The simplification part, we have done that a few times already, hopefully you're familiar with that. Now let's do the last example on this page. Okay, so f of x plus h minus f of x divided by h. So you have x, right? Take out the x, replace with x plus h. Do 3 minus x plus h. Then minus f of x, which is 3 minus x. All together divided by h. Okay, next, simplify the numerator as much as we can. First, distribute negative into this parentheses, distribute negative to the parentheses, and you get 3 minus x minus h minus 3 plus x all together divided by h. So positive 3, negative 3 cancel out, negative x and positive x cancel out, and you left with negative h over h, or negative 1 for that matter. Now for the next problem, it's a little bit more involved because you have a polynomial function of degree 2. Okay, but the process should be the same. Anytime you see x, you substitute by x plus h. So you do f of x plus h minus f of x divided by h. So you have x plus h squared minus x plus h plus 4. So what I just wrote down is the f of x plus h. Do you need the package?
Yes, please.
Right, so here, this is just f of x plus h. You might subtract f of x, which is x squared minus x plus 4. Altogether divided by h. Again, you simplify the numerator. What you do now is you expand x plus h squared. That means you do x plus x h, sorry, times x plus h. So here you have x plus h squared equal to x plus h times x plus h. You okay with this? Right, and then you FOIL it out. Okay. You should get x squared plus xh plus another xh plus h squared. Okay, so that's how you do it. And you combine the two middle terms together. You should get x squared plus 2 times xh plus h squared. So what I'm doing on the board, it's just that I'm expanding the term x plus h squared. Okay, that's what I did. So here I got on the numerator, the first term is x squared plus 2xh plus h squared. Then next, you have minus x minus h plus 4. Then you distribute this negative into the parentheses. You got negative x squared plus x minus 4 all together divided by h. Right, so combine like terms, make cancellation where you see possible, right? So x squared with negative x squared cancel out, right? So what else do you see? What else? Plus 4 minus 4, yes. What else? Right, so negative x and positive x. Right. So let's do that. So the x squared terms cancel out here. Negative x, positive x cancel out. Positive 4, negative 4 cancel out. And now you're left with 2xh plus h squared minus h all together divided by h. You follow the steps, man. Any questions? Any concerns? All right. So what is the next step? What do you think? Right. So on the numerator, you can see that all the three terms have h. Right. So h is a common factor on the numerator. You can pull that out. You left with 2x plus h minus 1 all together divided by h. Then you can simplify h at this point. And you're left with 2x plus h minus 1. Okay. So in the next example, you have the function f of x equal to 3x squared minus 2x plus 6. Can you actually spend a little bit of time on this problem? Try to do as much as you can. Follow whatever we have so far. Let me know if you have any questions, okay? I'm gonna give you like 1 or 2 minutes on this. So again, you start the problem with the formula f of x plus h minus f of x over h. Right. So for f of x plus h, you do 3 times x plus h squared minus 2 times x plus h plus 6 minus 3x squared minus 2x plus 6 altogether divided by h. So at this point, you're going to expand everything else and then by like terms to simplify the numerator. Right. So here, so x plus h squared, you can see on the board what we did here. So I have x squared plus 2xh plus h squared. Then minus 2x minus 2h plus 6 minus 3x squared plus 2x minus 6. Altogether divided by h. All right, so now next step, I will distribute 3 into the parentheses. And I got 3x squared plus 6xh plus 3h squared minus 2x minus 2h plus 6 minus 3x squared plus 2x minus 6. Altogether divided by h. Now you simplify as much as you can, right? So positive 3x squared, negative 3x squared cancel out. What else? Negative 2x, positive 2x. And then positive 6 and negative 6 cancel out. And you're left with 6xh plus 3h squared minus 2h altogether divided by h. Then on the numerator, h is the common factor. Therefore, you get h times 6x plus 3h minus 2 divided by h. And you cancel out the h, and you're left with just 6x plus 3h minus 2. Any questions? Good. So in this lecture, what we did is we look at the definitions of functions, right? And we try to classify if a relation is a function or not, right? Using all the property that we covered, the 4 properties that we covered at the beginning of the lecture. And toward the end of the lecture, we say that can you actually find the output of the function given some input? That is, can you do substitution, take out the x and replace that with something else? So that's what we did. The next topic is about graphs of functions. Okay, so we're gonna deal with graphs. You look at the graph and you identify if the graph represents a function or not. Okay, and we can do all sorts of things related to graphs. Can you find the domain of the graph of the function? Can you find the range of the function? Something like that.